Okay, well, let's continue with our discussion on the idea of representations of different functions. And we've so far only represented these functions in terms of them being ordered pairs of x, y values, right? So when we talked about it before, we were talking about those x, y pairs. But here's another representation of a function. This one, we have in one box a set of values that are matched somehow by some rule with the values in the next box. Well, in this case, the indication is that we're taking each of these numbers and matching them with the one that it points to. So 0 is matched with 1. 1 is matched with 2. 2 with 3, and so on and so forth. Does this represent a function? Well, sure. If we say that our domain is this set of numbers below here, and our range is this set of numbers here in gray, does this represent a function? Sure it does, right? Because each value from the domain, each value is matched with one value from the range. Right? So we're going to say that, yeah, this is a function. That makes perfect sense to me anyways, all right. Except that the writing here is terrible and my pen leaks that way. Awful. All right, let's try it again. Function. This does represent a function. All right. How about this representation over here? Would this count? Well, it looks like our domain is 0, 1, and 2, but each one of these numbers right here is matched with two values, right? So this is kind of like saying we have the pair 0, 0 as one of our ordered pairs in this set, but then we also have the set 0, 1. Well, as we saw before, that means that each value from the domain is matched with two values from the range. So yeah, this is not a function. Not a function. Well, what do we got below here? Well, let's take a look at this. Given an equation in x and y, well, this is a different kind of representation, right? There is actually a definition of functions that says that a function is essentially a rule of correspondence that assigns each value in each ordered pair to exactly one value in the ordered pair. And we've been looking at these set of values right here in our function that way. Sometimes there is actually a representation that looks kind of like this. The set of all values x and y such that there is some rule of assignment. And that rule of assignment is, generally speaking, an equation in x and y. Well, what is that rule of assignment? Well, for example, we could write, let's take 2x plus y, leaky pen, equals 3. This would be a rule that if you put in each value of x, you could get a value of y that goes with it. Or for every y, you can get an x that goes with it. But let's call this our rule of assignment right here. How can we tell whether this function, whether this equation represents y as a function of x? Well, the way you tell is that if you isolate y in the equation, and it results in one value of y for any one value of x input into the equation, then it is a function. And in this case, yeah, we could isolate y by subtracting 2x from both sides. So if I start out with 2x plus y equals 3, and I subtract 2x from both sides to get y on one side of the equation, thus isolating it, I find y is equal to negative 2x plus 3. And in this case, any one value of x that's input to the function results in one value of y out. What kind of expression might end up with 2? Well, let's see. What if we were told this? X squared plus y squared is equal to 4. How about that one? Well, if we try to isolate y in this case, what we turn up with is an expression that's not as easily dealt with. We get x squared plus y squared equals 4. So we subtract x squared from both sides to isolate y, pardon me. We end up with y squared is equal to 4 minus x squared. Now, how do we isolate y? Well, we haven't really learned too much about this yet, and we'll get into this in later chapters. But if you try to isolate y right here, the only way to undo a square is to use a square root. When we take the square root, we get y is equal to positive and negative the square root of the number on the other side, 4 minus x squared. This would not be a function because for any one value of x, you can get both a positive and negative value of y that goes with it. So in this first case, yeah, that's a function. In the second case, not a function. More in the next video.